In section 5.5 and in 5.6, we learned two basic techniques of integration: substitution and integration by parts. In 5.7, we'll be discussing additional techniques of integration. So for this first example, we're going to be covering trigonometric integrals. So when you look at the integration, integrating this first example, which is cosine cubed x, if we decided to substitute the cosine x, it's not really helpful, because if we take the derivative of that, it's going to be negative sine x dx. And in order for us to integrate the powers of cosine, we would then need an extra sine x factor. So what we're going to have to do is, go back and look at our trigonometric identities. And the one that we looked at in the past was sine squared x plus cosine squared x, which is equal to 1. And then if we wanted to solve for cosine squared x, we would know that that's equal to 1 minus the sine squared x. So therefore, what we can do is then rewrite cosine cubed x as cosine squared x times the cosine of x. And then from here we can then substitute cosine squared x with 1 minus the sine squared x times the cosine of x. So now we can evaluate the integral by substituting. So step number 3, what we're going to do is we're going to let u now equal sine of x. So therefore du is going to equal cosine x dx. Now let's go ahead and finish this up. So here we have our original problem, which is the cosine cubed x dx. And we factor that out to get cosine squared x times cosine of x dx. And then using our substitution, we know that cosine squared x is now being substituted for 1 minus the sine squared x times cosine of x dx. Now we can go ahead and use our substitution. So we know that 1 minus the sine squared x is now become 1 minus u squared times du. And so therefore, when we integrate from here, we know the antiderivative of 1 is u. The antiderivative of u squared is 1/3 u cubed, and that's plus the constant c. And so therefore, our result is the sine of x minus 1/3 sine cubed x plus c.